Hi, good evening, everyone. Hello. Yeah.
Hello.
Okay. Okay. Welcome to the Google Developer Space channel, and thank you very much for tuning in to the live stream tonight. I'm Lawrence from Google Developer Relations team, looking after our developer and startup community in Southeast Asia. Thank you for joining Go Singapore Meetup tonight, and we hope everyone is safe and well. Okay. Please do remember to leave your comment in the live chat, and then let us know where you're doing from. Okay. Before we begin our presentations, let me briefly introduce who we are and what we do. Google Developer Space is a home for developers and startups from around the region to learn, connect, engage, and inspire. Yeah, so for tonight's session, right, we are very excited to be hosting GoSG. And thanks, team, for bringing such a great line of speakers. Yeah, so right now I will hand the stage over to GoSG. Over to you, Stanley.
Thank you so much, Lawrence. And thanks Google Dev Space who have been always very kind to us and like offer us all this StreamYard stuff. But yeah, hey folks, so we are back for October edition. So it's almost a year. I think we are gonna complete this year with a monthly schedules, which is great. We have never done this before, right? But all right, yeah. So for today, we actually have two very exciting talks. So the first one is from Balaji, the co-founder of streetcard.com, and he'll be talking about how debuggers work. And for the second talk, we have Woon, our regular face, to talk about a crash course on Go templates. So uh, without further ado, let's welcome Balaji on the stage to talk about Debugger.
I'm Balaji. My meta name is Pune. I'm a co-founder at Stake. I have experience in distributed systems and networking. At my previous company, I used to work at dgraph and built a popular key value storage engine called Badger. At my free time, I building this tool called QuickLock. It's a remote debugging solution. In this talk, I'm gonna talk about how debugger works. So usually, how do we even debug a program? Let's say if you stuck into a problem, your code is not executing as you expected. The general logical step which we do next is that insert a print statement, or we use some debugging tools like Dell to debug the program. Uh, So for the folks who don't know what debugger is, I'll show you a quick demo how Dell works. So that like in order to understand how debugger works, we must know what a debugger is. Let's go to a small demo. Let's say I want to let's say I want to debug at the line number 12. I just have to click the breakpoint and run the debugger program. So the debugger runs the program and stops at the place where I want to stop. Then even I can see what is the variable to trace the value. Before executing this statement, the debugger passed the program and showing what is the variable. If I continue, you can see the logs in the debug console. Let's say the current variable value is 8674 something something. Let me continue the program. You can see that variable. Not just you can set a breakpoint, even you can do step in, you can go inside the print statement and see what is happening, and you can step out, and also you can run the instruction one by one, something like that. This is the main use case for the debugger. You can typically use to debug your program, where you can pass the execution of a program and expect what are the variable and values, and so on and so on. So we covered the basic functionalities of a debugger, breakpoint, step in, step out, and inspecting a variable. Right now we'll be checking how the breakpoint works in a debugger. So let's figure out what are the things we are fitting into a debugger. If you see the example here, we're just giving the source code of the program to the debugger. From the source code, what all we can actually derive. We can go build and get a binary. So we have a binary and a source code of the program. So let's say we have binary file which we want to debug and the source code. So our idea is to set a breakpoint at the line number 12, right? At the line number 12. How debugger finds the line number 12 in a binary file? Let's open a binary file and see. It's all full of some machine code which we don't understand. So we have to find this line number 12 in the entire binary file, which is hard. So in order to do that, debugger use something called DARF. DARF is a debug information that is kept along with this binary, which gives the mapping between the programming language and to your machine code. To take the to decode those infos, we use a tool called object dump. We just have to pass the binary as an input to this object dump tool, which outputs all the file number and its line number and its address at the binary file. Let's say our interest is the line number 12 and its address is 0x49233. So next, if you set the breakpoint and you run the program, it passes it. So how does this even debugger passes at the place where you want to do it, where you set the breakpoint? So the thing is, CPU passes the program whenever it sees the special instruction called 0xcc. So we just have to rewrite the instruction at 0x49888233 with the instruction 0xcc so that CPU pass the program at the address which you want to pass. So shall we rewrite the binary with the trap code? As you see earlier, our binary file is filled with all the machine code. So it's hard for us to always finding the assembly instruction and changing the hex code. So Linux give us a nice little system called ptrace. Ptrace is a system which help us to manipulate the memory of a program. So by using ptrace, we can rewrite the instruction at the address where we want to rewrite. So let's do a small recap before we get into a program so that we know what we are doing. So first we learned the mapping of the source code to the real instruction using that object tool. Then after we know how to pass the program, we just have to flip the instruction with 0xcc instruction. Then after we can do that by ptrace system call. Cool. Let's start a program. I have created this sample program, which typically what it does is that it just runs in a for loop and take a random integer will be allocated to variable to trace variable and prints it sleep, and it's keep printing the random integer in a loop. Then I've compiled this into a binary, which has some random machine code. I'm using a exec command to run the process and setting the ptrace flag true, so that I can the root process, parent process can do a ptrace system call on the child process. So we should keep this ptrace flag set to true. Let's start the program. As I told, rewriting the instruction at the address which we want to rewrite, there's a system called ptrace poke data. Ptrace poke data allow us to rewrite the instruction at the address where we want to rewrite. It takes the parameter of process ID, address, and the instruction you want to rewrite. So this is my set breakpoint function, which use ptrace poke data to rewrite the address with the trap instruction. But before this ptrace poke data, I'm using something called ptrace peek data, which is nothing but the reverse of the ptrace poke data, which reads the data at the address. I'll tell you later why I'm reading the data at the address. Then we can continue the program and wait for the trap to come. So for that we use ptrace continue and ptrace wait. So how do we even resume the program? This is where it gets tricky. I'll explain in the code why it's get tricky. Let's say we have fmt.print statement here. This is the place we want to pass. So while setting the breakpoint, we change the fmt.print statement instruction with 0xcc. Then we got the trap. So when we resume the program, the print statement won't execute because at that address space we have 0xcc. So the right way in order to execute the print statement, we have to revert back to fmt.print statement. So the next thing to resume a program, first we have to revert back to the original data, which we reverted it back. If we continue the program, will it print the variable? No, because this statement is already executed, so it won't resume it won't run the fmt.print instruction. Instead of it goes to the time.sleep. So what we do is that, if you guys are studied in uni about register, CPU register, instruction pointer holds the next instruction to get executed. So we have to manipulate the register of the CPU to tell what is the next instruction which needs to be executed. For that, we use this thing called ptrace get registers and ptrace set registers. I'll show you how we are resetting in the whole the next block. I'll give you how small intro. What is this? How do we manipulate the registers? So we read the CPU registers by using this unix.ptrace.get register. We take the registers and we set the address which instruction we want to execute again in the instruction pointer, and we set the register back using ptrace set register, so that it execute the instruction which we want to execute. So let's go to the debugger program. You can see that we initially this is 0x49233 is the line number 12. Here we want to set the breakpoint. So we read the original instruction which is on that address space in a variable called data. At the same address, we changing with the trap code called 0xcc, and set breakpoint returns that original instruction which is at the line number 12. This is the original. Then after we continue the execution and we wait for the breakpoint to hit. When the breakpoint hit, we simply print a statement called breakpoint hit. Then after we resetting the breakpoint. which is that flow which I explained before, like print statement. Then we have to change the 0xcc with the original instruction which we collected during the set breakpoint. So this is the original data. We just using poke data. We just setting the original data. Then after, in order to re-execute the same instruction again, we just setting the instruction pointer of this, the address which we want to execute again. Then after, we do a single instruction execution, because if we run the program, it keep running, it doesn't stops at the line number 12 again, because the line number 12 has the original instruction. So what we do is that we execute a single instruction, we wait for the instruction to execute, then after we set the breakpoint again, so that whenever the next time the line number 12 executes, the program stops. Then I just put everything in a loop and driving this program. If you see that I'm running the sample binary, which stops the program at line number 12. When the line number 12, when the program is passed at the line number 12, our debugger program prints breakpoint head. Then after it reset the breakpoint, which means that it execute the print statement and set the breakpoint again, then it goes again. So the final output would be, before the sample program prints the variable, we see this breakpoint hit from the root program. Let's run and see. You can see that the breakpoint hit happened. Then after the sample program, the control is went to the sample program, the print state, the variable to trace has been printed. Then after we set the breakpoint and the reset breakpoint, it went here, the trap code executed. Then we went to this debugger program, the breakpoint hit. Then after, when we do the reset breakpoint, then the number has been printed again. So this is how the debugger, these are the technologies which Delve uses to build the debugger. Yeah, from the talk we learned what is the mapping between how debugger maps the source code with the binary file. Then after, we also learned how debugger pass the program with 0xcc trap instruction, and also we learned how debugger manipulate the register to do the execution flow in a right way. So my pet project QuickLog also use debugger to do the production system debugging. I'll show you a quick demo how QuickLog works. Let me close this. The thing is, when it comes to debugger, it works well with the local system, but when we run the debugger in the production, it's hard, because like debugger only accept one client, but in a typical company, we'll have like multiple developers who wants to debug the same application, and those kind of things. And also debugger opens a port where people has to open the firewall and stuff, but QuickLog works in push based mechanism. Instead of you don't need to configure your outbound rules, because the inbound rules, the QuickLog pushes the debugging information to the manager. So how QuickLog works is that it has an agent called QuickLog. Then we have to create a config which has the agent token and the binary which you want to run. Then you can simply do QuickLog agent on your production server. Let's say tomorrow you want to know what is the request amount that's happening on the production. You're debugging something. So typically what you do is that you put fmt.print statement uh, then req.amount, then you build the binary and build the Docker and push it to the production and you debug it. Instead of that, what you can do is that once after you integrate quick log, you can directly open your VS Code and do add log point. Let's say GoSG demo log point, and the variable you want to expect that you can put it in the curly braces req.amount. Sorry, amount and click enter, then you run the extension, the quick log extension. Let's hit the postman collection and see. Let's do like 7. Let's hit enter. You can see that has been printed in our debug console. GoSG demo log.7. So if you guys are curious to know about Quakelog, you can go to quakelog.dev and know about Quakelog, and also you can join our Discord server to ask questions about Quakelog. Thank you guys. If you have any questions, please ask.
Okay, thank you for the presentation, Balaji. There's one question from David Chua.
Yeah.
Do you know which slide this is? Oh,
Which?
there's a nice Kakashi GIF. Yeah.
GIF.
No, I mean, going back to this question. There's an address of line 12, like somewhere before your demo.
So the line. Well, yeah.
Yeah. How do you know the address? Is it printed or something?
This is though using this object tool. So what happens is that whenever you do a let's say let me open that. Yeah, whenever you build a binary, so let's say go build dot.
Oh, can you shift your screen a bit higher? The bubble is blocking your command line. Is it possible?
Which one?
Yeah. Okay.
Okay. So when you do a go build, you get a binary. What Go compiler does is that in the binary, it not just include the assembly instruction, it also includes the debug information called dash, which has the mapping of the address to the line number 12. That has been decoded. That can be like, if you consider Delve, they have a parser which reads the binary and they build the AST tree out of the dark code. I'm not sure AST tree, but they have an internal data structure for the dark code. But instead of I am doing that, passing the binary, I'm using this Linux tool called objdump, which decode the which gives an output something similar like this, which gives you the mapping of the line number to that address. I'll show you a real output, maybe like it looks like. So when you do a objdump, you get something like this, entire output of all the file and its address. I just copied the relevant information which needed for this presentation.
Okay. Yeah, I think you answered the question and you even demoed. Thank you. So it looks like there aren't any more questions. Feel free to come in and post your questions on YouTube or Facebook. If you have any questions, anybody. Oh yeah, you answered this question. He replied with thanks. Okay, so looks like there's no more questions. So we will be taking a break now. So everybody, you can go to the Gather Town link. There's also in the Meetup page. Just go over there and we can have a chit chat with our speakers and everybody. you just feel free to go to whoever you want to speak to and just say hi and then start a conversation. The link is in the meetup. So thank you again for Balaji for the presentation. Can you go to the last slide so that in case anybody wants to contact you?
Last slide, right? Yeah.
The one with your contact. Yeah, so for all those who is viewing this on recording, you can contact Balaji on this. Thank you very much. So see you
Thank
guys
you.
all in Gather Town. We'll be back here for the second talk at 8. Yes,
Thank you.
thank you. Okay, welcome back. Yeah, so we'll be starting our next presentation, which is by Woon on a crash course on Go templates. So basically, he'll do a quick talk and everything you need to know about Go templates. So template composition, syntax and variables, functions, methods, and pipes. So without further ado, let's have Woon start his presentation. Remember to unmute first, Woon.
Hello? Okay, cool.
Yep, we can hear you.
Let me find my window back again. Okay, so hi, my name is Woon. I'm a developer at TeckWah, and TeckWah is a packaging and printing and logistics company focused on warehousing. But they're not really Go related. I use Java at work. Or rather, the contents for this talk came after I tried writing my blog from scratch. So I had to learn about HTML template in depth. Okay, so this talk is in 3 parts. So like as already introduced, so I guess I won't cover this slide. Okay, so part 0 actually, introduction to Go templates. So what are templates? They are most commonly used to generate HTML, i.e. web pages. There may be other users, but I'll focus mainly on HTML. And a sample output may look something like this at the bottom of the slide. Okay, so here's the hello example. There are 2 files, hello.html and common.html. And hello.html will first call a template called header, then it'll print a line, and then it'll print another template called footer. And in common.html, I'll define a template called header, and I'll define a template called footer. And this is all tied together by using pass files. And then I will pass it into a template variable, and I execute this template variable to standard out using a map string where my name is set to Woon. And the output looks something like this. You will have your header, your I guess the content, and then my name, and then after that the footer. So very straightforward. However, Go's templating system is not like the others. So you may have experience with some other templating engines like Django templates, Jinja 2, Laravel Blade. Their template references are essentially static. So you will include a sub-template by referencing its file path in some template directory. So for example, you may say include partials header.html, and this will reference a file inside a file system. But in Go, these template references are all dynamic, and you must compose the templates yourself. So when you say something like template header, you don't really know which template this header is pointing to because it doesn't reference anything in the file system. It depends on what templates you compose, which brings me to part 1, template composition, which is an underdocumented aspect of Go templates. By the way, if you have any questions, just post them in the chat and I'll answer them at the end. Okay, so the big idea is that a template is essentially a map string template data structure. Anytime you do template composition, you're essentially populating this map string template structure. Okay, so on the left-hand side, I have a template file, and on the right-hand side, I'll have the template structure, the map string template structure that it translates to. So if you call pass files like hello.html, you essentially end up with a template that has 3 templates in it. So you have a hello.html template, and then a footer template, which is from this block here, and a copyright template, which is from this block here. When you execute a line like template footer, you are essentially consulting this map string template structure and pulling out the corresponding template in order to execute it. So once you call footer, it will look up the template, and then it will run this template body footer. And then when you're running a template body footer, it will encounter this line template copyright. So it will again consult this map looking for the template called copyright, and then it will execute a template body. So that's how this lookup system works. So this is another example, the hello world example translated to the same map string template. Now we have 2 files, hello.html, which, well, it's the same thing, and then the common.html. Okay, so it translates into a map string template structure that looks like that on the right. So now you have 4 templates within this structure, hello.html, common.html, header, and footer. So essentially a template is a map string template, and one of these templates inside the map is marked as the current template. So I'll go through this block of code on the right, line by line, just to explain what I mean. Okay, so on the left is our sample map string template data structure, and on the right is the code that will I guess if you run it, you'll see these results. Okay, so if you call template.name, you'll get the name of the current template. If you execute the template, you will execute the current template. Okay, if you just call execute, but you can execute any template within this structure by calling execute template and passing in the template name. So if you pass in header, you're actually executing this template. Oops. And if you execute footer, you're actually executing this template. And you can iterate show templates using t.templates, which will just, it's a slice, by the way. So it takes the stuff in this map and converts it into a slice. So the order is actually not defined. You can't rely on any defined order. If you just want the names of the templates inside this structure, you just do t.define templates and it'll return a string with all the names inside. It's, I think, mostly for diagnostic purposes. If you do lookup header, something like t.lookup header, it actually returns the same template structure, but the current template is set to this template they're looking up. So if you do this, it returns a new template where the current template is now set to header. And then since I assign it back to T, then T's current template is now header. So now if you execute it, you're executing the header template. And if you check the name, you actually get header. And if you look up a template that doesn't exist, you get a nil pointer. So you should be checking your template, checking your pointers diligently. So does Go support nested templates? Even though you have a template that looks like a sub-template definition that looks like as though header is a sub-template that belongs to Commodore HTML, what actually happens is everything gets translated into this map string template structure. So they all exist as equals. So this code on the right actually is equivalent to the code. I mean, the code on the left is equivalent to the code on the right. So here you're essentially doing hello.html, common.html, you pass nothing because there's nothing other than these two templates. And then you separately pass a header and separately pass a footer. It actually doesn't matter whether you put this header inside common.html or hello.html because they will all be elevated into the same map string template structure anyway. Then do Go template support template inheritance? Kind of, it's just this same template composition rules that we have been following all along. So why is template inheritance used? Quite often you have a page that pages will be quite similar except for some content in the middle. So for example, you have the same header, same footer, then when you visit this URL, let's say blog post, you want to include this template called index.html. But if you visit a different URL, you still have the same header, you still have the same footer, but you want to include a different template called post.html. The problem is that these includes only point to a specific template in the file system. It's a static reference, so it cannot point to different templates depending on the context. So some people created this concept called template inheritance where you define a parent template. So in here, I'm defining a base template, I'm defining a block called content, and then I'm defining a child template which extends the parent template and it redefines the block content. And then I'll define another child that extends the same parent template and redefines block content to a different set of output. So looking at base.html, you don't actually know what this block will render because a child may override it. And that brings me to this point where Go templates don't need template inheritance because the references are already dynamically resolved, right? So if you want to change a template to render a different thing, you just overwrite its entry inside this map string template. So in here, it's the same thing. You have a base.html, a template content, and then I'm invoking a template content and I'm immediately defining it. But at the same time, in a separate file, I'm going to define it again. And in another file, I'm going to define it one more time. So looking at base.html, this line right here, you don't actually know what this template content is going to render because if you passed it with base.html, index.html, you're going to render this content. If you pass this and this, you render this content. Or if you pass base.html alone, then you'll render this content. So in fact, Go templates have this block keyword that essentially does the same thing, right? So if you say block content, this is a placeholder, yeah, it's equivalent to defining, equivalent to calling a template called content, and then you're defining it. And then someone else can always overwrite it. It's just syntactic sugar for template followed by define. Okay, so part one, any questions about template composition? Actually, I can't really see a comments right now, so I'll just skip this slide, maybe towards the end. Okay, so part 2 is syntax and variables. Go's template syntax is very minimal. There's only like 6 keywords you have to know, and half of them are already covered in part 1, define, template, and block. So that only leaves the other 3. There's if, with, and range. Anything else that you can use in a template is a template function. Okay, so before we can talk about those, we must first talk about template variables. So every template has access to exactly one variable denoted by the dot. So this is whatever variable you pass to execute or execute template. Okay, so let's say your dot variable is a struct that looks something like this, right? Params, author, first name, John Doe. The dot will refer to this entire thing, whereas dot params dot author dot last name refers to this specific last name Doe over here. And similarly, if you have your dot as a mat string interface, a nested mat string interface, right? So you've got params, mat string interface, author, last name. It's exactly the same thing. The dot refers to this entire thing. And if you do dot params dot author dot last name, you're doing the same thing where you will look up params, author, last name. So why this works is because Go templates basically uses reflection. So it doesn't really care whether you pass in structs or not. It will just read these strings in, and then after that, dynamically resolve it based on reflection. Alternatively, for maps, you can use this template function called index. So index followed by a map, followed by the map keys. So this line right here is equivalent to this, where you pass in the map, then you want to index, get the params key, followed by the author key, followed by the last name key. Only for maps, not for structs. Okay, so variables must be explicitly passed down to these templates. So for example, if I define a template called footer and I access some kind of variable in it, and if I call this template called footer without passing in anything, it fails because it will try to invoke this thing on a nil variable. You must pass this dot down, then this line will pass. You could also pass a subset of the variables down. So if you define a footer like this, dot first name, then you can pass like params dot author, and then it will pass this subset down, and then this first name variable reference would just work. So variables can be assigned and reassigned. So you have this, you can assign this. You don't want to type this, you can assign to a variable and then use it everywhere, or you could reassign it just like Go. So in Go, you declare variables using this colon equals, then you assign existing variable using equals, same thing. And the scope of a variable exists until the end of the current block. So if it's either if end or with end or range end or just a current template. Okay, so now you have this if, else end. This is a if statement which you should already know. So it looks something like if some variable, and then you print this, otherwise you print this. And evaluation is truthy and falsy. Okay, so the falsy values are false, 0, nil, and the empty array slice mat string. So if this variable is any of these, it's considered false, and everything else is considered true. So I used to write code that looked like this, where you would say, if this length of the users equals to 0, then I do this. But you don't have to do that, because if you can just do if users, because an empty slice is already considered false. So this is a lot more readable. Okay, so now I'll talk about the dot and the dollar. The dot refers to the current template variable. So you've already seen the dot will print a variable. You could do a nested access by doing dot params dot user dot first name. But the dollar also refers to the current template variable. So you can do dollar, it's the variable. You can do a nested access by doing $params dot user dot first name. The difference is that this dot will change depending on the context. And there are only 2 instances where it would change context, inside with blocks and range blocks. On the other hand, the dollar will always point at the current template variable. It never changes context. And we will see this in this example with the with keyword with variable end. First off, it behaves like an if. Okay, so if variable is falsy, this block is not executed at all. But otherwise, the dot is set to the variable inside this with block. So if you want to access anything outside the dot, you must use the dollar. An example, let's say our template variable looks like this, okay? User, first name, last name. So with user first name, inside this block, the dot is now the first name. So that's John. If I do first name dot, I print John. But I want to access the last name and the dot is John. So I need to take the top level $sign, which still references the entire thing, $.user.last name. And you can also assign it to a variable, and then you can use it everywhere. So the dot is still the same, except you can now use first name for dot also. It's just more readable, so you don't have this weird cryptic dot everywhere. So the last keyword is range. So it loops over this variable, and the variable must be an array, a slice, map, or channel. And if there are 0 elements, then the else block inside here is executed. So again, the dot is changed to each successive element inside the array, slice, map, or channel. If you want to access anything outside the dot, use the dollar. So this is a basic example. You range users. Inside this block, the dot is now set to this John Doe, and then it is set to Jane Doe. And if you want to access today, which is outside this slice, you must use the dollar. Alternatively, you can also assign it to a variable. So now if you assign to a variable, the dot is equal to the user, the first name is equal to user.firstname. And same thing, today is still accessed the same way. And lastly, you can use index to the two variable syntax, I guess. So if users is a slice, I will be the index, user will be the value, and everything follows. But if this thing here is a map, then this is the key and this is the value instead. So yeah, key, and then the dot is set to the value. For maps, if the order, if I'm not wrong, is if the key is sortable, it will be iterated in the sorted order. Otherwise, if it's not sortable, comparable, yeah, if they can be compared using the double equal sign, then it'll be sorted. Otherwise, it won't be sorted. Okay, so the part 3 is functions, methods, and pipes. So templates already have some default functions that you can already use. So there's AND. So you can do if AND, condition, 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 as many conditions as you want. It will gather them up and then it will run the AND on all of them. Or you could use the OR, which is the other equivalent, the OR equivalent, or the NOT, which is just accepts one condition and then AND. There's length, which will check the length of a variable, where the variable is either a string, a slice, an array, map, or channel. Or you could use index. If you do index a slice, you must pass in numbers and you'll access the slice elements. If you pass in a map, you can pass in the key elements and you'll access the map accordingly. However, templates can call user-defined functions. So this is how you can really extend your templates, I guess. So let's say you define a new template, you define a greet function using this funcs method, and then you can use it inside your code. So like greet Bob, it'll print it'll print hello Bob. These functions can take any number of arguments but must return one result. So you can return a string, an interface, or custom type, whatever. You can optionally return an error additionally, and if this error return is non-nil, it will halt the template execution. Templates can also call methods. So if you have a type user and you have a greet method on this user, if you parse, if you've got something like user.greetBob, then you just pass in the user. You do it like this, it'll basically call the method implicitly, and then you can pass the arguments in. So this will print hello Bob as well, same as just now. However, if you're trying to call a variable, like templates cannot directly call variables that just happen to be functions. If you want to do that, you must use the call function. Okay, so here I'm user has a greet function variable, and I'm passing in a variable, but in order to use it, I must use call.user.greet Bob, and then I will be able to print hello Bob. And the result of one function can be piped into another function. So when you pipe it, the result is passed in as the last argument to the next function. So for example, in here I have two functions. One is called upper, which is just strings dot to upper, and I have the greet, which is takes in the greeting and the name, and then it will return the greeting plus the name. So if I pass it, I do upper dot. That means I'll upper the argument, and then I'll pass it to the last argument to this greet hello, So what actually comes out here is hello Bob, because I pass in Bob over here. It gets uppercase and then it passes into hello Bob like that. Yep. Okay, so this is the end. There's some stuff I didn't cover, which I'm just gonna glide through it like really quick. Templates can be parsed separately and then combined together. Okay, so if you do that, you're basically merging these two map string template data structures. If two templates combine together, then templates may have functions associated with them. How do they interact with each other? Which function will win if two functions have the same name? So the functions are just map string interfaces. They also get merged together using the same logic. So one will override the other. HTML template will automatically secure your HTML, CSS, JS, and your URL input for you. So it will escape them based on the context. So it knows whether it's inside a HTML block, CSS block, JS block, or inside URL. And even the upcoming break and continue keywords will respect this. So you will not be able to break and continue in a way that will cause the block to change. So maybe I don't really know how to explain it. You'll find out eventually. Yeah. Okay. So functions must be defined before you pass them. So if you pass and then you pass some string that uses a function, it must be defined inside the template before you use it. However, once it's passed, you can overwrite it with any kind of function. So I don't really know why they have the first this restriction to begin with. If you can do this and then just unleash like some weird stuff on it. Yeah. So that's all. That's the last slide. If any questions, I can address them now.
Okay, thank you for the talk, Woon. That was very informative, learning about templates, dot, dollar, and everything. So we have a question from our regular, Siwin. So I'll show it on the chat. Why is there a current template?
I guess. I mean, that's just how it works, I guess. So, it's just so that you can execute and then you don't have to explicitly pass in a template name, as I can understand it. So you can just execute it, and since there's a concept of a current template, whatever you execute will be the current template. Yeah.
Okay, so it's probably just like a helpful feature to have a current template, the one that's being used now.
Yeah. I think there was some others. Was there some other template? Current template. Oh, I can. As far as I can tell, that's the only benefit, lah. Yeah.
Okay. So his follow-up question
is
why is there execute and then there's also another one called execute template? Yeah,
I mean,
over there.
That's I do think that this also means that you can actually, off a single template, you can put your entire website stuff into it, right? All your pages, as long as the names don't override. So you can actually, inside a single template, you want to generate as long as, because maybe they'll use the same dependencies, right? So maybe the header template is always the same, footer template always the same. You can always render a different template depending on the situation, and they will all reference the same templates within this map string template structure. So space efficiency, I don't know, man. They're all pointers, so I don't think I don't think it's very expensive to duplicate it, but yeah.
Yeah, I think shouldn't be very expensive to duplicate pointers. Probably just for convenience already.
Yeah.
So So one more question. This is pretty long. Have you tried using Go templates to generate actual code? If yes, how do you do unit tests to ensure that the code generated is? I think you can answer the first question first. Have you used Go templates to generate code?
Yes, I have actually. One of my other projects got used templates to generate code. Funny thing, I used to think that the cleanest way to generate code was to use the GoSG package, like to dynamically create an AST and then print it into a file. But that is so complicated. Like that's so, I don't know, man. Yeah, basically the correct way is to use templates. That's a much easier, more streamlined way. Okay, so I have done that. it wasn't code though. It was just struct definitions. I think a lot of packages will do that. A lot of Docker probably does it. Like anything that if you want to overcome any Go shortcomings, you can just use code generation as a tool. So yeah, and to ensure that the code generated is functioning code, actually, if I'm not wrong, you can also use the Go. There's a Go package, one of the AST plugins. You can basically feed in a string and ensure that it's valid Go code. So you can ensure that it's semantically correct. I think you can do, yeah. So I haven't done that though. Actually, I'm not really familiar with that, but basically, yeah, you can do that lah. The thing is, I only learned about this when someone submitted a pull request for my project that used this feature where basically they pass in the string, the generated code back into the Go parser to ensure that what came out was correct Go output. Yeah. So I'm not familiar with using that, but cool. That's possible. Yeah. Any ideas for this? Yeah. That's possible lah. I can't remember what the package name is called. Parse ast.parse or something.
Okay, so he has a follow-up question. What if the code, okay, so there's a correction to that. So I'll just read out the correction. What if the code that is to be generated is not Golang code? Maybe it's like JavaScript or Python.
Oh, that sounds super like a
meta.
yeah, it's like in a realm where I don't know, man. That sounds like you need to pull in an interpreter. Or if not, honestly, right, Go is a language where a lot of the answer is just don't do it. You know, you can override package global variables like io.eof. Okay, just don't do it. So I think in this case, it's just ensure you don't write bugs, lor. Yeah.
Okay. I think we'll hang around and wait a bit more if people have any questions. So I'll do a advertisement again. So later we'll be hanging around in the Gather Town. So please feel free to connect to Gather Town. We only have like I think 10 people inside, so there's a lot of vacancy. Anybody can just join in. So oh yeah, do you have a like last page of your contact in case people want to contact you outside of this session?
I didn't prepare one, but
okay.
I think
your
more
first page
important
is it there? Okay.
Oh yeah. Let me put it there.
It should be right in
Actually, it's
front.
this. I think I don't have any information.
This one, yeah.
Yeah. Okay.
Anyway, he's on Meetup also. So if you want to contact him, you can drop him a message on Meetup. Shouldn't be a problem. Okay, I don't see any more questions coming in. So thank you, Bokun, for being our very informative speaker on templates. So I did learn a thing or two about templates also. So thank you for your presentation. And
cool.
everybody, please join Gather Town so that you can check with the speakers and everything. So if you have like any questions that you might think up later, just directly go to our speakers, ask them the questions, or maybe for example you can ask Bokun how to contact him if you're interested. Yeah. Okay. Thank you very much. See you all next month. We're planning one for next month, so we'll announce when it's closer to the date. Yep. Thank you very much. See you all in Gather Town. Bye-bye.
Bye.